Hello, everybody, and welcome to Dot to Dot. Today, we're going to talk about the three circles of Oak Island. These are the continuation of the decoding of the Xena Halper map. And these circles are very important to the expansion of the geometric progression to the different spots that are to be located on Oak Island. So, we're going to go to Google Earth, and here on my last week, I showed the right triangle and how it is uh, corresponds to the triangle of De Pierre, and how it basically is associated with the stone triangle. I've taken that off. We'll put that back up later on. But most importantly, and how it is associated with the south anchor, and that it basically shows that we must go due south to locate the south anchor. Now, this distance to the south anchor is the same distance to this called the 429 extension, which is the distance from cone D to the headstone transferred over to equal distance to this point. And this distance from here to La Hampe, which is the center of the quadrant of the Rochefoucauld map. And there's the Rochefoucauld map, or the Xena Halper map, and it is the center. And so we come due south to the south anchor. So with the circles, we know that this distance from cone E to the north anchor, we've reasoned that it is the same as the distance that we did when we did the scale to the Frog Island. Remember, we did this scale, and this is how we determined the orientation of the geometry. And this is the scale. Notice also, I don't know if I mentioned before, but the 1347 distance is also to the center of the quadrant, and it goes to there. And we'll get into this distance also in a minute. But on this, in this geometry, we have this scale of 1347. And how do we get this? One of the things I want to show you is in a past video I did on 1347 is that the way it is written in French is 1347 would not have an un in front of it, a un, which is not the number one. It's actually an article. And when you write a date, because we all thought it was a date, it would start off with just the mille. It would not say un mille for 1,000. So this is showing that the date, it is not a date because of the way it's written. And you can see right here, see it's written un mille trois cent quarante sept. 1347, but it's saying a 1347. So why is that there, that un? Well, I think it's there because it is basically telling us that the 1347 isn't really a distance. It is, or it's not really a date. It is a unit of measure to be taken as a whole, just like in these examples here, like un mille, which stands for a mile. And Olivier from Oak Island Research was looking into that because the way he read it, and he's a French national, he thought it meant a mile because that's the way you would write a mile. A mile is written un mille. That's a mile. Same with a foot, un pied, and same with an inch, un pouce, or pouce, whatever. So the fact is that it may be that this is supposed to be a unit of measure that is going to be used. And when we employ that unit of measure, 1444, in the form of circles, and we put one at the ends of the extended Nolan's cross here, one on the north anchor and one on cone E, and one on the south anchor, which we just discovered. So what we find is that on the Zena-Halper map, we find that the intersection of the north and south anchor intersect at the position that is, let me put the landmark back up, triangle 2. And this is where we think that triangle 2 is supposed to be located geometrically on the Zena-Halper map. Another one that we have from the cone E circle is it goes through close to the hole under the trap door. But yet we only have one reference to that. So we don't know the location of that, but I'll show you that in a later video. But this right here shows it's going through the hole under the trap door. The other thing it indicates is where this 1347 intersects the 45 degree, and this is what we call the oak. We used to call it the oak entrance or the money pit, but if you remember on this map, it says the oak, enter here. So this is not where you enter. This information will not be provided really on this map unless you incorporate the stone triangle, which we know is not on this map. The stone triangle is only referred through the 45 degree angle of the triangle de Pierre, and the stone triangle is something that's actually on the island. So basically what this map is doing is giving you a general area of where these major locations are going to be, and this would be the oak. And triangle 2 is now the gateway to the west. So what we do on the west side of the island is going to start from triangle 2. And this is basically what the 3 circles do, is they give us a positions to start on both the east side of the island, which we will find the place where the entrance to the tunnel will be, and the west side of the island, where we will find the entrance to go underground to shut off the to divert the waters of the flood tunnel system to lower the vault so you can enter the vault. So this is the 3 circles of the Zena-Halper map. One thing I want to show you that is not by accident is that if you notice, you remember there's always going to be these references to true north. And if we take from cone E and go up to the intersection or the end of the Vesica Pisces, we will be drawing a line that is directly due north-south, and the same with the north anchor. This is not a coincidence. This is not by accident. This is by design. And the reason is because they are used when you're drawing this, because this is not surveyed on the island. This is the solution is figured out by drawing it on a piece of paper or on a map. So this is used as a north-south reference. So when you measure this angle that is going to triangle 2, you will have it. Same with cone E. When you have the line coming going to the oak entrance or to the oak, you have a line, you have a reference of true north to this right here. So it's the 1347 scale ends up being a standard of measure that will be used to locate and to solve the geometry of the Zena-Halper map. Now, another thing I want to show you too is that, remember, I had the stone triangle down there. And this is very interesting because I think even though the stone triangle isn't located on the Zena-Halper map in the position, it's only located through the triangle de Pierre. It has an interesting correlation to not only the landing, but also to the 1347 scale. And if you take the position of the stone triangle as the center circle, you get this circle, big circle that comes out. If you take it to the end here of this line, which was the line that extended to Frog Island. Let me put the map up. If you remember, wrong one. Remember, we're supposed to go to here to extend that line out to here. If you extend that line out to here, this distance right here to that circle is 3 times 1347. So this line is 3 times. So if you took your dividers 3 times, it would go out to this circle. And this circle intersects also at an equal distance to the stones on Round Island, which line up, these stones line up I have a better picture here I can put up. These stones line up there's a better picture. These stones right here line up the east-west line, which is important in the orientation of the map. So this is something that is very interesting, and the correlation between the stone triangle, the map, and the consistency of which the 1347 is used, not only in finding the different locations, triangle 2, the hole under the trap door, but also in the distance that it is from cone E to the north anchor is 1347. So that's the circles, and these are the circles of Oak Island and how they relate to the geometry that is on the Zena-Halper map, decoding the Zena-Halper map. Thanks for watching. I'll talk to you later. Like and subscribe. Goodbye.